Let's start with differential calculus, a quick revision. This we have already done in class 11th. So let's start with some standard functions. Derivatives of some standard function. Derivative of x raised to the power n is nx raised to the power n minus 1. Derivative of e raised to the power x is e raised to the power x. Derivative of log x is 1 upon x. Derivative of a raised to the power x is a raised to the power x log a. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of sec x is sec x tan x. Derivative of cosec x is minus cosec x cot x. Derivative of cot x is minus cosec square x. And derivative of constant is 0. So these are the things that we have already done. Now some rules for differentiation. Derivative of sum or difference of a function is du by dx plus minus dv by dx. Derivative of sum is sum of derivatives. Constant into derivative of constant into fx is constant into derivative of fx. Product rule is given by, let u be a function of x and v be a function of x. U is fx and v is gx. Then derivative of fx into gx, that is derivative of u into v, is first function into derivative of second plus second function into derivative of first. This is called product rule, and we have done many questions based on this in class 11th. This is division rule. Derivative of fx upon gx, that is derivative of u upon v. Denominator into derivative of numerator minus numerator into derivative of denominator upon denominator square. This is division rule when there is a quotient of two functions. Now we have chain rule. This is derivative of function of a function. Suppose y is a function of t and t is a function of x, then dy by dx is given by dy by dt into dt by dx. So this will give you dy by dx. This is called chain rule. This is function of a function. Let's do few problems based on chain rule. Let y is equals to tan root x. So we put root x is equals to t. Then y becomes tan t and t is root x. So first we find dy by dt and then dt by dx. Applying chain rule. So this is dy by dt is x square t and dt by dx. Derivative of root x is 1 upon 2 root x. So dy by dx is dy by dt into dt by dx. That is sec square t into 1 upon 2 root x. Now substitute for t. T is root x. So finally we get sec square root x into 1 upon 2 root x. This is derivative of tan root x. Let's take another one. Y is equals to e raised to the power root cot x. So put cot x is equals to t and root t is equals to u. So this is e raised to the power u. Now dy by du. This is e raised to the power u. Derivative of e raised to the power u is e raised to the power u. And du by dt, that is 1 upon 2 root t. And dt by dx, that is minus cosec square x. Derivative of cot x is minus cosec square x. So finally it is e raised to the power minus e raised to the power root cot x upon 2 root cot x into cosec square x. So wherever, when we finish the differentiation, we just substitute for t, u and all that. Another example. Now we'll do it directly. Y is equals to log sine 2x. First we will differentiate log sine 2x. So it is log t. Take sine 2x as t. So this is 1 upon sine 2x. Log sine, this is log t. So 1 upon t into derivative of sine 2x is cos 2x and derivative of 2x is 2. So this is finally the answer. 1 upon sine 2x into cos 2x into 2. Another one, let y is equals to log x cube. So dy by dx is 1 upon, we'll take this as t. So this is log t, 1 upon log t, that is 1 upon log x cube. Then we'll differentiate log x cube. So this becomes 1 upon log x cube. Then derivative of log x cube, this is 1 upon x cube. And then derivative of x cube, it is 3x square. So this is how we apply chain rule. Another one, y is equals to root log sine x. So dy by dx is 1 upon, first we'll take this as whole, root log sine x, 1 upon 2 root log sine x. Then we'll differentiate log sine x, that is 1 upon sine x. And then we'll differentiate sine x. Derivative of sine x is cos x. So applying chain rule, we take this. Then let's take one more. Y is equals to root ax square plus bx plus c. So dy by dx is, we'll take this as whole, 1 upon 2 root ax square plus bx plus c. And then derivative of ax square plus bx plus c is 2ax plus b. Another one, y is equals to e raised to the power root tan x. Then derivative of e raised to the power root tan x, e raised to the power root tan x. Derivative of root tan x is 1 upon 2 root tan x. And derivative of tan x is sec square x. This is how we apply chain rule, and that is the rule for differentiation of function of a function. All these things you have done in class 11th. We have done quite difficult questions also there. Now we'll start with derivatives of inverse trigonometric functions. Though you have not done inverse trigonometric functions, because as per me, I would like to teach on board that inverse functions. So what are inverse functions, inverse trigonometric functions? You just try to take this. If sine pi by 6 is 1 by 2, then sine inverse 1 by 2 is pi by 6. This is defined in a particular range. Cos pi by 4 is 1 upon root 2, then cos inverse 1 upon root 2 is pi by 4. That is, if y is equals to sine theta, then sine inverse y is theta. This is inverse trigonometric function, and this we will be doing separately. Now we are going to revise. We are going to find the derivative of each and every inverse trigonometric function. So let's start with y is equals to sine inverse x. Y is sine inverse x. It means x is sine y. Then dx upon dy is cos y. Reciprocate this. Dy by dx is equals to 1 upon cos y. That is 1 upon root 1 minus sine square y. That is 1 upon root 1 minus x square. So derivative of sine inverse x is 1 upon root 1 minus x square. Similarly, y is equals to cos inverse x. It is defined in open interval minus 1 to 1. So x is cos y. Then dx upon dy is minus sine y. Reciprocate this. Dy by dx is minus 1 upon sine y. That is minus 1 upon root 1 minus cos square y minus 1 upon root 1 minus x square, because cos y is x. So derivative of cos inverse x is minus 1 upon root 1 minus x square. Similarly, we'll take y is equals to tan inverse x, where x belongs to R, that is set of real numbers. Put x is equals to tan y. Then dx upon dy is sec square y. dy by dx is 1 upon sec square y. So dy by dx is 1 upon 1 plus tan square y. So dy by dx is 1 upon 1 plus x square. Similarly, we can find the derivative of cot inverse x. Derivative of cot inverse x, using the same technique, we get minus 1 upon 1 plus cot square y, that is minus 1 upon 1 plus x square. Then y is equals to sec inverse x. So x is sec y. Dx upon dy is sec y tan y. Dy by dx is 1 upon sec y tan y. We just reciprocate this. So it is 1 upon sec y, and tan y can be written as root sec square y minus 1. So this derivative of sec inverse x is 1 upon x into root x square minus 1. And similarly, we can find the derivative of cosec inverse x. Y is cosec inverse x, so x is cosec y. Dx upon dy is minus cosec y cot y, and dy by dx is minus 1 upon y cosec y cot y, that is minus 1 upon cosec y into root cosec square y minus 1. So this is minus 1 upon x root x square minus 1. So this is how we find the derivatives of all the trigonometric functions. Here this is the summary. Derivative of sine inverse x is 1 upon root 1 minus x square. Derivative of cos inverse x is minus 1 upon root 1 minus x square. Derivative of tan inverse x is 1 upon 1 plus x square. Derivative of cot inverse x is minus 1 upon 1 plus x square. Derivative of sec inverse x is 1 upon x root x square minus 1. And derivative of cosec inverse x is minus 1 upon x root x square 1. X square minus 1. So these are the derivatives of inverse trigonometric functions. And from next class, we'll be differentiating various types of functions. We'll start with derivatives of inverse trigonometric functions. Then we'll go for derivatives of implicit functions, derivatives using logarithmic functions, and many more things. So just go through the class.